This is question 31 from SC Verma in electrical current in conductors. We have a hexagon a wire in the form, this is bent in the form of a hexagon A, B, C, D, E, F, and the resistance of the wire is 15 ohm. And then we need to find, once it has been bent like this, we need to find the resistance, equivalent resistance. If we measure the resistance between points A and B first, between A and C, across A and C, and then finally across A and D. The first thing you need to notice is that 15 ohm is the resistance of the whole hexagon, not just one part of it, and that is the one mistake you may want to avoid. So let's say if 15 ohm is the resistance of the whole hexagon, then the resistance of one arm of it will be 15 by 6, or you can simplify it to 5 by 2. So what we will do is we will just write R in each of these sections, resistance of each of the sections of this hexagon, R, 6 R. And then the resistance between A and B is given by, let us try to find out the resistance between A and B. When we are trying to find the equivalent resistance between A and B, then we have this resistance R between A and B, and all other 5 resistors are in series, 1, 2, 3, 4, 5. So the equivalent resistance of these 5 series resistors will be 5R. And then the equivalent resistance of these 2 resistors in parallel is given by R1 into R2 divided by R1 plus R2. 5R into R, 5R into R divided by 5R plus R, 5R into R divided by 6R. R cancels, we have 5 by 6R, and then we know that R is 5 by 2. So it's 25 by 2 or 25 by 12 or 2.08. When you need to find out the resistance between across A and C, we have this series resistor RR, that becomes 2R, and then R becomes 4R. So we have the equivalent resistance, something that looks something like this, RR and then 4R here, which is equivalent to 4R and 2R, and their equivalent resistance is going to be 4R into 2R divided by 4R plus 2R, or 4 into 2, 8R divided by 6R, which is 4 by 3R. And we know that the R value of R is 5 by 2, so it's 5 into 2, 10 divided by 3 is equal to 3.33 ohm. And finally, the equivalent resistance between A and D will be the 3R resistors in series, and then another 3 resistors here, that becomes 3R and 3R resistors in parallel, something like this, and its equivalent resistance is going to be 3R divided by 2, or 3 by 2 multiplied by 5 by 2, 15 by 4, or 3.75 ohm.